Hello, welcome to Succeed e-learning app. Today we are going to learn about triangles. In your previous classes, you have learned about triangle and various properties of it. So today we are going to learn about similar triangles. So let us quickly recollect what we had learned about triangles previously. So I would like to talk about one of the properties, that is congruency of figures. So any figure which has same size and same shape is called as congruent figure. For example, two circles, if they have same radii, is called as congruent circle. Two squares, if they have same size length, that is called as congruent square. So let us talk about similar figures. So what are similar figures? So let's talk in general before we get into the definition of it. Similar figures are those which looks very similar to our eyes. For example, let's take volleyball and a football. So for us, to an outsider who sees it, it looks very similar. But in terms of size, it might be different. The shape might be the same, but the size might be different. So similar figures are those figures for which the sizes differs, but the shapes looks alike. For example, two or more squares which have different side lengths still looks very similar to us, but are of different sizes. Two or more circles which are of different radius looks very similar, but then they're of different sizes because of their change in radius. Two or more triangle with different side lengths looks very similar to us in terms of shape, but not in terms of size. So all of these are the example of similar figures. From this discussion, we can say that two congruent figures look very similar and they can be called as similar, but not all the similar figures can be called as congruent. So let us consider a quick example about this. Let us consider two equilateral triangles, one with a side length of 2 centimeters, other with a side length of 4 centimeters. So both the triangles, as we have learnt in our previous classes, equilateral triangles will have 60 degree on each of its corner. So both of it have same angles but have the proportional side lengths. So to generalize, any two polygons which has same number of sides can be called as similar figures if it satisfies two conditions. One, it should have proportionate side lengths. Two, it should have the same or equal angles. So here, equilateral triangles were the best example to understand what were similar figures. One, for the reason you saw that both of them had 60 degree each angles. Two, because the side lengths were different, but still both of them looked similar. Criteria for similarity of triangles. We have already discussed that there are two criteria for the triangles to be similar. One, their corresponding side has to be of same proportion. Two, their corresponding angles have to be equal. So now, let us consider triangle ABC and triangle DEF. So here we see that AB divided by side DE is equal to AC divided by side DF is equal to side BC divided by side EF. And also, if angle A is equal to angle D and angle B is equal to angle E and angle C is equal to angle F, then we call these two triangles are similar. So we represent this as triangle ABC is similar to triangle DEF. So this symbol is actually representing is similar to. So let us move on to a theorem. So in this theorem, it states that if in two triangles the corresponding angles are equal, then their corresponding sides are said to be in equal ratio or proportion. So such triangles are called as similar triangles. So now let us consider two triangles, triangle ABC and triangles DEF, such that angle A of triangle ABC is equal to angle D of triangle DEF and angle B is equal to angle E, and angle C is equal to angle F. So now consider a point P in the line DE of triangle DEF in such a way that DP measures the same as AB. Now mark a point Q in the line DF of triangle DEF in such a way that DQ is equal to AC of triangle ABC. Now join P and Q. So now you can see that angle B of triangle ABC is equal to angle P of triangle DPQ and angle E is also equal to angle P. So this is because we have studied about the corresponding angles of parallel lines. Now this also will lead to angle criterion of two triangles. So this says that triangle ABC is similar to triangle DPQ. Now we talked about the three similar angles and two triangles being similar. So now let us say it in different terms. So in any two triangles, if the corresponding angles are equal, then two triangles are called as similar. So does it require all the three angles to be same? No. If we have two angles of a triangle which is same or equal to two angles of another triangle, then these two triangles can be called as similar. So moving on to the next theorem. We now just discussed about the angle criterion of the similarity of triangles. Now let us talk about the side criterion of the similarity of triangles. So if in two triangles, if we have the corresponding sides are equal, then we say that the corresponding angles are similar. Then we call those two triangles as similar triangles. So now let us consider the same two triangles which we talked about in the previous theorem. So triangle ABC and triangle DEF with P and Q intersecting DE and DF respectively. So we had learnt that PQ is parallel to EF and angle B is equal to angle P is equal to angle E. So with this, what we understand is angle ABC of the triangle is equal to angle DPQ of triangle DPQ. So now we call these two triangles as similar triangles. So angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F of triangle ABC and triangle DEF. Moving on to next theorem. So this theorem states that the ratio of area of two similar triangles is equal to the square of the ratio of their corresponding sides. So now let us consider two triangles, triangle ABC and triangle PQR. Draw a point M and point N in triangle ABC and triangle PQR respectively in such a way that M intersects BC exactly at 90 degree and mark A and M. Now draw a point N from P in such a way that it intersects at 90 degree on line QR. Now let us calculate the area of triangle ABC. The formula for area of a triangle is half into base into height. So here the base for triangle ABC is BC and height is AM. So triangle ABC is equal to half into BC into AM. Similarly, the area of triangle PQR is equal to half into QR into PN. Now we know the side criterion and the angle criterion of the triangles. So from this figure we know that angle M and angle N are 90 degree each, which means AMC triangle and triangle PNR are similar. Similarly, triangle ABM and triangle PQN are similar. So now with this fact we understand that angle B is equal to angle Q and angle M is equal to angle N. Moving forward, we understood that triangle ABM is similar to triangle PQN with respect to the angle criterion that we deferred. Now with all of this we understand that if we take the proportion of triangle ABM to triangle PQN, that will be equal to side square, which is BM divided with QN, the whole square. Pythagoras theorem. In your previous classes, you have learnt about Pythagoras theorem, which says that the square on the hypotenuse is equal to the sum of the squares of the other two sides. Now, let us consider a right angle triangle, triangle ABC, which is angled at B. So, the angle B is equal to 90 degrees. Now, let us mark a point D perpendicular to AC from point B, such that angle D is also equal to 90 degrees. Considering the fact that angle ABC is equal to 90 degree and angle BDC is also equal to 90 degree, we can say that triangle ADB is similar to triangle ABC. So, we have studied about the side and the angle criterion of the similarity of triangles. With this, we can say that side AD and side AC when multiplied with each other is equal to AB square. Consider this as equation 1. Also, in triangle BDC is similar to triangle ABC, which implies that CD into AC is equal to BC square. Consider this as equation 2. Now, add equation 1 and equation 2. With this, we get AD dot AC plus CD dot AC is equal to AB square plus BC square. Now, AC is common in your left hand side. Take out AC. So, AC within the bracket AD plus CD is equal to AB square plus BC square. Now, if you consider AD and CD, we see that AC is divided by D, which means AD plus CD will form AC. With this, we can say that AC dot AC is equal to AB square plus BC square, which is nothing but AC square is equal to AB square plus BC square. Hence, Pythagoras theorem is proved with the similarity of triangles. So, let us move on to one last theorem of this chapter. So, we have discussed about the Pythagoras theorem, which says square on the hypotenuse is equal to the sum of the square on the other two sides. So, hypotenuse is a side which is opposite to the 90-degree angle of a triangle. So, let us put it across in a different way. Now, let us say as square of one side, if it is equal to the sum of squares of other two sides, then an angle which is opposite to the first side is 90 degree. Now, let us consider a triangle ABC and a triangle PQR. So, let us consider PQR in such a way that angle Q is equal to 90 degree, then PQ is equal to AB and side QR is equal to BC. Since we know that angle Q is equal to 90 degree, let us consider triangle PQR. Here, side PR is hypotenuse. So, PR square is equal to PQ square plus QR square. Or we can also say it in other way, that is PR square is equal to AB square plus BC square. How did we find that? That is because triangle PQR and triangle ABC are similar. Remember the side and the angle criterion of these two triangles. Now, side AB is equal to PQ and BC is equal to QR. This is because of the construction. Therefore, side AC is equal to side QR. That is, if two sides of one triangle is equal to two sides of another triangle, then we can conclude that the other remaining sides of both the triangles are equal. Which also implies that triangle ABC has an angle B which is equal to angle Q of triangle PQR. Since we know that angle Q is 90 degree, this proves that angle B of ABC is also equal to 90 degree, which says that this theorem is proved. We have come to the end of chapter Triangles. Now let us quickly recall what we have learnt all through the chapters. In this chapter, you have studied the following points. Two figures having the same shape but not necessarily the same size are called similar figures. All the congruent figures are similar, but the converse is not true. Two polygons of the same number of sides are similar if it satisfies the two condition. If their corresponding angles are equal and their corresponding sides are in the same ratio or proportion. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, then the other two sides are divided in the same ratio. If a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. Angle, angle, angle similarity criterion. If in two triangles, corresponding angles are equal, then their corresponding sides are in the same ratio and hence the two triangles are similar. If in two triangles, two angles of one triangle are respectively equal to the two angles of the other triangle, then the two triangles are similar. This is also called as AA similarity criterion. Side, side, side similarity criterion. If in two triangles, corresponding sides are in the same ratio, then their corresponding angles are equal and hence the triangles are similar. Side, angle, side similarity criterion. If one angle of a triangle is equal to one angle of another triangle and the sides including these angles are in the same ratio or proportion, then the triangles are similar. The ratio of the areas of two similar triangles is equal to the square of the ratio of their corresponding sides. This is Pythagoras theorem. If a perpendicular is drawn from the vertex of the right angle of a right angle triangle to the hypotenuse, then the triangles on both sides of the perpendiculars are similar to the whole triangle and also to each other. Pythagoras theorem. In a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. If in a triangle, square of one side is equal to the sum of the squares of the other two sides, then the angle opposite to the first side is the right angle. This is also called as converse of Pythagoras theorem. So this concludes the chapter Triangle. I hope you enjoyed learning with us. So for more such videos, continue watching Succeed e-learning app.